Okay, so we're going to be calculating the empirical formula. They give us that if a 0.872 gram sample of an unknown organic substance. Now, for the purposes of this video, you could probably assume that this is going to be burning a fossil fuel, like a hydrocarbon. As far as that goes, I just made the assumption that we were going to have CH as our unknown organic substance. Anyways, this undergoes a complete combustion, producing 2.64 grams of CO2 and 1.08 grams of H2O. Determine the empirical formula of the unknown substance. So, one of the key features in balancing chemical equations is that the moles on each side of the equation, either via subscript or coefficient, will always be equal. So what I mean is that when you multiply, whether it's balanced or not, right, you're under the assumption that you have balanced it, even though we haven't, because at the end of the day, whether you multiply times a coefficient and a subscript and you get X amount of carbon, for example, then doing the same thing and adding in your subscripts and coefficients over here will give you the same amount of carbon on this side. So once again, that is one of the key features in balancing chemical equations, that if you do it right, when you multiply and add everything, when all is said and done for the left and right sides of this equation, you will get the same thing. That makes this problem substantially easier because, or more easy, because we don't really have to worry about balancing the equation, which is one of the things I almost initially got stumped on, and I remembered, wait a minute, there's this fact here. So I'll do another video where I do the matrix method, and that's how this one is set up actually. So it kind of dawned on me, well, when you're doing the matrix method, you make that assumption, right? You assign it variables. We're not doing this here. We're simply just using this idea, given that we have 2.64 grams of CO2 and 1.8 grams of H2O on the right side. You're probably wondering, well, then how are we going to get hydrogen and carbon over here? Well, you're going to get that through using stoichiometry. I'll show you how that's done here. So I went ahead and set it up as CXHY. Don't worry, there's not going to be any algebra here. It's just so we can understand what I just previously said. So they gave us 2.64 grams of carbon dioxide. 1 mole of carbon dioxide is 44 grams of CO2. You cancel your grams, you get 0.06 mole of CO2. Do the same thing for the H2O that they gave us. So 1.08 grams of H2O, water, multiplied times 1 mole of H2O per every 18 grams of H2O gives us 0.06 moles of H2O. So once we have this information, we can go ahead and we can use our stoichiometry. Now there's 1 carbon, right, to every 1 CO2 as given. So you can make this assumption here from the CO2 that we're dealing with. We're not messing with 1 carbon on this side. No, no, no. We're saying that we have 1 carbon in this CO2 compound. So that means 1 carbon per every 1 CO2. Thus, if you want to know how much carbon you have for your left side, all you have to do is take that 0.06 mole of CO2 and multiply it times 1 carbon per 1 CO2, cancel your CO2s, that's 0.06 mole of carbon. You repeat that process for the 0.6 mole of H2O because you witness that there's 2 hydrogen per every 1 H2O. So then that means that we're going to take the 0.06 moles of H2O, we're going to multiply it to the 2 hydrogens in H2O per every 1 H2O. Again, there's 2 hydrogens in 1 H2O, so this is your ratio that you set up, just like we did with the carbon. You get 0.12 mole of hydrogen. Now, once you have both of these values, we're to the point where we can determine our empirical formula by dividing by the smallest number element that we have in here. That's 0.06 mole of carbon, so we just divide by 0.06 in both of these expressions down here. And then what you'll get is 1 carbon, of course, and then you'll get 2 hydrogen. And there we have it. Then the empirical formula for the unknown substance, C sub x H sub y, is C1H2 or CH2. So, as written, that would be a very volatile compound. But this is the math that I calculated in this problem, so we'll just leave it there. If there's an issue, then just go ahead and let me know, and I'll fix it for you. All right, so Nerd Ferguson.